6. Changes around us. Changes around us. When one or more properties of a thing become different, we say that it has changed or a change has taken place in it. Changes involve different kinds of alterations in the things around us. These alterations are due to some cause. Let us take an example of ice and water. When ice melts, it forms water. So the melting of ice involves a change in state from solid state to liquid state. Some of the important changes observed by us in our everyday life are A. Formation of curd from milk. B. Cooking of food. C. Burning of fuels. D. Drying of clothes. And E. Rusting of iron. Classification of changes. A substance undergoes a change to form a new substance only when certain agents like heat, light, electricity or force, etc. are applied to it. For example, when sugar is mixed with water, it dissolves in water to form sugar solution. Now, dissolving sugar in water is a change which has been brought about by mixing other substance, water, to sugar. Some of the changes can be reversed, whereas other changes cannot be reversed. So all the changes around us can be classified into two groups, A. Reversible changes and B. Irreversible changes. A. Reversible changes. A change which can be reversed to form the original substance is called a reversible change. Let us understand the example in detail. We all know ice is a solid substance. When we heat ice, it melts to form water, which is a liquid. A change from solid state to liquid state takes place during the melting of ice. When we cool water, it freezes to form ice again. In this case, a change from liquid state to solid state takes place. Thus, the melting of ice to form water is a reversible change. This reversible change can be represented as follows. Ice, solid. When heated, becomes water, liquid. When cools, become ice. It can also be represented with the help of a diagram as shown below. Expansion of an object on heating is a reversible change. When an object is heated, it increases in size. The increase in size on heating is called expansion. The expansion of an object on heating is a reversible change. When the hot object is cooled, it decreases in size and comes back to the original size. The decrease in size of an object on cooling is called contraction. The reversible change of expansion is used A. In fixing an iron rim on the wooden wheel of a cart, and B. In fixing the iron blade of a digging tool like a spade to a wooden handle. 1. Fixing of iron rim to the wooden wheel of a cart. The iron rim is fitted around a wooden wheel by the process of expansion on heating or followed by contraction on cooling. This is done as follows. The iron rim is made slightly smaller than the wooden wheel around which it is to be fitted. The iron rim is heated uniformly by making a fire due to which it expands and becomes somewhat bigger in size. Being bigger in size, the hot iron rim is easily put around the wooden wheel. Cold water is then poured over the hot rim to cool it. On cooling, the hot iron rim contracts, becomes slightly smaller in size, and fits tightly onto the wooden wheel. 2. Fixing of iron blade of a digging tool to a wooden handle. The iron blade of a soil digging tool, like a spade, is fixed to a wooden handle by the process of expansion on heating, followed by contraction on cooling. This is done as follows. The iron blade of spade has a ring in which the wooden handle is to be fixed. The iron ring of spade blade is made slightly smaller than the thickness of the wooden handle which is to be fixed in it. To fix the handle, the ring of iron blade of spade is heated over a fire. On heating, the iron ring expands and becomes slightly bigger in size. One end of the wooden handle now easily passes through the hot ring. Cold water is then poured over the hot ring of the spade blade to cool it. On cooling, the hot ring of spade blade contracts, becomes smaller in size, and fits tightly onto the wooden handle. Irreversible changes, a change which cannot be reversed to form the original substance or substances, is called an irreversible change. For example, rusting of iron and setting of plaster of Paris (POP). Let us illustrate examples in detail. Example 1. Burning piece of paper. If we burn a piece of paper, it changes into ash and smoke. Now we cannot combine the ash and smoke to form the original piece of paper, so the burning of paper is a change which cannot be reversed. In other words, the burning of paper is an irreversible change. Example 2. Setting of plaster of Paris (POP). Plaster of Paris is a white powdery substance which immediately sets to a hard mass on adding water to it. In hospitals, a thick coat of the paste of plaster of Paris is applied over the bandage on the fractured bone of a person. POP sets and becomes hard on drying and keeps the fractured bone in place to get joined properly. The change which occurs in POP during setting cannot be reversed. Thus, the setting of plaster of Paris on mixing water is an irreversible change. Reversible and irreversible changes involving same materials. 1. Folding of paper and cutting of paper. The folding of paper is a reversible change. Let us cut a sheet of paper into number of pieces. We cannot combine the various pieces of paper to get back exactly the original sheet of paper. Thus, the cutting of paper is an irreversible change. 2. Rolling a roti. Let us take some dough, kneaded flour, and make a ball of it. Add water to powdered flour. Knead the mixture of water and powdered flour to make a dough. Make small balls from the dough. Roll the small balls of dough into a circular roti by using a rolling pin, belan. Now, if we want, we can convert this rolled roti back into the ball of dough. This means that the rolling of roti out of dough is a change which can be reversed. Thus, the rolling of roti out of dough is a reversible change. Baking of rolled roti on tawa. Let us now bake the rolled out roti on a tawa kept on a stove. We will get a baked roti. Now the baked roti cannot be changed back into the original ball of dough. The baking of roti is a change which cannot be reversed. Thus baking of roti is an irreversible change. 3. Inflating a balloon. Let us do an activity of inflating air in balloon. Take a balloon. Blow air into it. You will see the shape and size of balloon change after getting inflated. Now we will allow the air filled in the balloon to escape. We will find that when all the air escapes, the balloon comes back to its original shape and size. Thus, inflating a balloon is a reversible change. Bursting of balloon. Let us do an activity for bursting of balloon. Take a balloon. Blow air into it so that it gets inflated to its full size. Tie the mouth of the balloon tightly with a thread. Press the balloon between the palms of your hands. The balloon bursts. This burst balloon cannot be changed back to its original shape and size. Thus, the change which occurs during the bursting is an irreversible change. 5. Melting of wax. Wax is a solid substance. Let us do an activity to see melting of solid wax into liquid wax on heating. Activity 1. Converting solid wax into liquid wax on heating. Take some wax in a porcelain dish and heat it over a burner. On heating, solid wax melts to form a liquid which is called molten wax or melted wax. Now remove the burner and allow the molten wax to cool down. On cooling, the molten wax or liquid wax becomes solid again. We saw that solid wax melts on heating and melted wax becomes solid on cooling. The melting of wax is a reversible change. Burning of wax. A candle is made of wax. Let us do an activity to see what happens when we light a candle with a matchstick. Activity 2. Lighting a candle with a matchstick. Take a small wax candle. Measure its length with a scale. Fix this candle on a tile kept on a table. Light it with a burning matchstick. Allow the candle to burn for 15 to 20 minutes. Now blow out the burning candle and measure its length again. We will find that the length of this remaining candle is much less than its original length. This happens as follows. When we light the candle, then the wax present in it starts burning to produce heat and light. The burning of wax also produces carbon dioxide gas, water vapor, and soot, unburned carbon particles, which all go into air. We cannot combine all the products of burning of wax to get back the original candle. Thus the burning of wax is an irreversible change.